Here are the lesson 6.3 examples that I did in class. Some people have forgotten what I explained, so here's a chance for you to revisit that information. The first example I did was if f of x is 7x to the 1/2 power minus 2 and g of x is negative x to the 1/2 power plus 4, we can do two things. One of those is to add f of x plus g of x, and the other one is to subtract f of x minus g of x. When I add them, I have 7x to the 1/2 minus 2 plus negative x to the 1/2 plus 4. Combining my like terms, 7x to the 1/2 minus x to the 1/2 is 6x to the 1/2 power. Negative 2 and positive 4 makes plus 2. So f of x plus g of x equals 6x to the 1/2 power plus 2. If I subtract, I have 7x to the 1/2 power minus 2 minus negative x to the 1/2 power plus 4. This time, because I'm subtracting, you've got to remember to distribute this negative. So it's 7x to the 1/2 power minus 2 plus x to the 1/2 power minus 4. Combining my like terms is going to give me 8x to the 1/2 power minus 6. So that is f of x minus g of x. The next set of examples I did were using the equations f of x equals 4x squared and g of x equals negative 3x to the 4/3 power. And with these two equations, I multiplied them. So first I have f of x, which is 4x squared, times g of x, which is negative 3x to the 4/3 power. In this situation, I'm going to multiply my coefficients. So 4 times negative 3 is negative 12. I'm going to keep x because that's the base here and here. And then the exponents are going to be added. So I'm going to do 2 plus 4/3. 2 plus 4/3 is 10 over 3. If you're not sure about 2 plus 4/3 on your own, then use a calculator and you can double check with my math. For part B, when you take g of x and you divide by f of x, negative 3x to the 4/3 power divided by 4x squared. First I look at my coefficients, so I have negative 3 over 4, which does not simplify. I keep x because it's my base. I'm going to subtract my exponent, so 4/3 minus 2 turns out to be negative 2/3. When I have a negative in my exponent, it tells me to move it to the denominator of my problem. So my problem becomes negative 3 over 4x to the positive 2/3 power, because when you move the exponent, it changes it from being negative to being positive. The last type of problem I did was called composition, where we do f of g of x and g of f of x. For f of g of x, we take the g function and we plug it into the f. So I'm going to take the g function right here and plug it into the x of the f function. So that means I have 2x plus 3. So I have 2 times where my x was plus 3. I left that blank so that I could put g of x in there, and that's where the 3 over x plus 1 goes. Now I've composed my two functions, and I can simplify a little bit. 2 times 3 is 6 over x plus 1 plus 3 gives me the answer of f of g of x. Then when I do g of f of x, I'm going to go the opposite direction. So I'm going to take 2x plus 3, which is my f of x. I'm going to plug it into the x right here for the g. So in the g function, I have 3 over something plus 1. That something is where my x used to be, and in that place I'm going to put 2x plus 3 because that's the f of x function. Simplifying this, I get 3 over 2x plus 4. I worked all of these examples in class on Monday and Tuesday of this week, so they should be in your notes, but in case you've forgotten how they go, that's your examples, and your assignment was page 100, 1 through 18 all.